Magnets are fascinating objects that have been used for centuries in a variety of applications, from compasses to motors to medical imaging. At the heart of the magnet's power is the magnetic field, which is a fundamental force that exists throughout the universe. Magnetic fields are generated by moving electric charges, such as electrons, and they can exert a force on other electrically charged particles. When we think of magnets, we often picture the familiar bar-shaped objects that are attracted to iron, but magnets come in many shapes and sizes and can be made from a variety of materials. Magnets can be classified into two broad categories: permanent magnets and electromagnets. Permanent magnets are made from materials such as iron, nickel, and cobalt, and they have a magnetic field that is always present. Electromagnets, on the other hand, are made by passing an electric current through a wire, which generates a magnetic field that can be turned on and off by controlling the flow of electricity. The magnetic field generated by a magnet is a vector field, which means that it has both a direction and a magnitude. The direction of the magnetic field is given by the orientation of the magnet, with the north pole of a magnet pointing towards the Earth's north magnetic pole. The strength of the magnetic field is measured in units of Tesla, T, or Gauss, G, with 1 Tesla equal to 10,000 Gauss. The magnetic field can exert a force on other objects that are in its vicinity, such as other magnets or electrically charged particles. This force is known as the magnetic force, and it is a fundamental force that plays an important role in many physical processes, including the operation of motors, generators, and other electrical devices. In addition to its practical applications, the study of magnets and magnetic fields has led to many important discoveries in physics, including the development of Maxwell's equations, which describe the behavior of electromagnetic waves. Today, magnets and magnetic fields continue to be an active area of research, with new applications and technologies being developed all the time. Magnets and magnetic fields have several important characteristics that are fundamental to their behavior and applications. These characteristics include magnetic field strength. The strength of a magnetic field is determined by the magnitude of the magnetic force it exerts on other objects. This strength is measured in units of Tesla, T, or Gauss, G. Magnetic field direction. The direction of a magnetic field is determined by the orientation of the magnet that generates it. The magnetic field lines always flow from the north pole to the south pole of the magnet, forming a closed loop. Magnetic field polarity. Magnets have two opposite poles, north and south, which are determined by the orientation of the magnet's atomic structure. Opposite poles attract each other, while like poles repel each other. Magnetic field distribution. The distribution of a magnetic field depends on the shape and orientation of the magnet that generates it. Some magnets, such as bar magnets, have a relatively uniform magnetic field across their surface, while others, such as horseshoe magnets, have a stronger magnetic field at their poles. Magnetic field decay. The strength of a magnetic field can decay over time due to factors such as temperature, mechanical stress, and external magnetic fields. Magnetic field shielding. Magnetic fields can be shielded or redirected by materials such as iron or steel. This property is used in many applications, such as magnetic shielding in electronic devices. Magnetic fields and electricity. A magnetic field can induce an electric current in a conductor, and an electric current can generate a magnetic field. This relationship is fundamental to the operation of many electrical devices, such as motors and generators. Understanding the characteristics of magnets and magnetic fields is essential for designing and optimizing applications in a variety of fields, including engineering, physics, and materials science. There are several types of magnets and magnetic fields, each with unique properties and applications. Here are some of the most common types. Permanent magnets. Permanent magnets are the most common type of magnet and retain their magnetism over a long period. They are made from materials such as iron, nickel, cobalt, and rare earth metals like neodymium and samarium cobalt. Electromagnets. Electromagnets are temporary magnets that produce a magnetic field when an electric current is applied. They are commonly used in electric motors, generators, and other electrical devices. Superconducting magnets. Superconducting magnets are electromagnets that use superconducting materials to achieve very high magnetic fields. They are used in magnetic resonance imaging, MRI, machines and particle accelerators. Ferromagnetic materials. Ferromagnetic materials are materials that can be magnetized when exposed to a magnetic field. They include iron, nickel, and cobalt and are used in many applications, including electrical transformers and motors. Diamagnetic materials. Diamagnetic materials are materials that are not attracted to a magnetic field. They include copper, silver, and gold. Paramagnetic materials. Paramagnetic materials are materials that are weakly attracted to a magnetic field. They include aluminium, platinum, and titanium. Magnetic fields of the Earth. The Earth has a magnetic field, which is generated by the movement of molten iron in the Earth's core. The magnetic field protects the Earth from harmful solar radiation and is used by animals such as birds and turtles for navigation. Magnets and magnetic fields have a wide range of applications in various industries and fields. Here are some practical examples of their uses. Electric motors. Magnets are an essential component of electric motors, which convert electrical energy into mechanical energy. Motors use a rotating magnetic field to generate torque and produce motion. Magnetic storage. Magnets are used in hard drives and other data storage devices to store and read data. The data is encoded on the magnetic surface of the disk and read by a magnetic read-write head. MRI machines. Magnetic resonance imaging, MRI, machines use strong magnetic fields to produce detailed images of the inside of the body. The magnetic fields align the hydrogen atoms in the body, which emit radio waves that are detected by the machine. Compasses. Magnets have been used in compasses for centuries to navigate and find direction. A compass needle aligns itself with the Earth's magnetic field, pointing towards magnetic north. Magnetic levitation. Magnets can be used to create levitation, which is the suspension of an object in midair without any physical support. This technology is used in maglev trains and other transportation systems. Magnetic separation. Magnets can be used to separate magnetic materials from non-magnetic materials. This process is used in recycling facilities to separate ferrous metals from other materials. Speakers. Speakers use magnets and electromagnets to convert electrical signals into sound waves. The electrical current causes the electromagnet to vibrate, which produces sound waves that can be heard. Magnetic locks. Magnets can be used to secure doors and other objects. Magnetic locks use an electromagnet to keep the lock engaged, and the magnet releases when an electrical current is applied. These are just a few examples of the many practical applications of magnets and magnetic fields. The unique properties of magnetic fields make them valuable in many industries, including healthcare, transportation, electronics, and manufacturing.